Question number 13, A part deals with, yes, fusion. What is fusion process? And B part deals with comparison. What is fusion? First part. Yes. Again we refer back to binding energy graph. Binding energy per nucleon. And it is number of nucleons, mass number. The graph is of this type. In this zone, yes, binding energy per nucleon is less. In this zone, binding energy per nucleon is more. So fusion process is, yes, process in which small nuclei combine. Combine means to fuse, combine to form relatively bigger nuclei. Example. First example is what? Yes. 1s2 combining with 1s2 gives what? Helium plus a neutron plus energy. How much? 3.27 mega electron volt energy. This is one example. 2. Yes. Second example is, yes, 1h2 gives you what? Yes. Result is 1h3 plus, yes, 1. This is 4 minus 3, 1 plus how much energy? 4.03 mega electron volt energy. The order is 3 to 4 mega electron volt energy. Why this process takes place? Yes, binding energy per nucleon for small is less. They combine to get more binding energy per nucleon, means what? To have more stability. So purpose is what? Stability, as shown in the graph. Time with you is 3 minutes to write. Comparison of fission and fusion. Both are termed as nuclear reactions. Both are source of huge amount of energy. Fission is what? Breaking a big nuclei into relatively smaller nuclei. Fusion is, yes, combining small nuclei to give a bigger nuclei. In sequence. Point number 1. Both nuclear fission and fusion are source of tremendous energy. Both give high energy. Of what order? Mega electron volt per reaction. Point number 1. 2. Energy per reaction. Yes. Energy per reaction. Energy per reaction for fission. Yes. What was the energy? 200 mega electron volt in one reaction. Uranium, one reaction energy release of the order of 200 mega electron volt is more than energy per reaction for fusion. Order. This is of the order of 200 mega electron volt. This is of the order of 3, 4 mega electron volt. 3. Energy per unit mass. Energy per unit mass. Yes. In uranium, mass is say 235. Energy release is 200. So energy release is 200 divided by 235. Here mass is 4 AMU. Energy is also 4. So here energy per unit mass is 4 divided by 4, say 1. In this case it is less than 1. That means what? Energy per unit mass for fusion, objective questions, is less than energy per unit mass for fusion. Sorry, for fission. As an example, 200 divided by 235 comes out to be less than 1. This is of the order of 1 mega electron volt. 4. Nuclear fission may precede nuclear fusion because for fusion suitable energy is to be made available by raising the temperature. Fission, for fusion, first part, temperature required is high. Why? You need to combine two nuclei. When you bring two nuclei close, the force is very high, repulsive force is very high. So that means you will have to move these two nucleons with very high kinetic energy, then they can combine. Very high kinetic energy, in this case temperature of the order of 10 raised to the power 7 Kelvin. How you get this temperature? By fission process. That means in order to have a hydrogen bomb, before that you will have to explode atom bomb. That is fusion. For fusion, temperature required is high. Of what order? 10 raised to the power 7 Kelvin. We may need fission first to cause fusion. Time with you is 4 minutes to write. Point number 5. In both the process, certain mass disappears. It is based on what? Energy mass equivalence. Means what? Energy is equal to delta m into c square. But delta m is what? Mass defect. Point number 6. Disposal. Yes. End product. For fission, end product is radioactive. That means what? It is environment issue. That is why disposal is not easy, difficult. What is the process? End product of this reaction, that is nuclear power plant, take that material in a container, thick steel container, where you place it seabed, so that it will decay in maybe 100 years time. That is why disposal of the end product, that is in process fission, is not easy, difficult process. Nuclear radioactive material, if it is exposed, then it is a big environment threat, will lead to cancer. For fusion, yes, end product is not radioactive, disposal is easy. Let us complete this. Disposal is easy. Last point, control. Yes, which of the two is easily controllable? Fission. Control is easy. Fusion, control is not easy, is difficult. Why? In fusion, once the temperature reaches a certain value, above that no instrument, nothing can control this. Temperature of the order of 1 lakh, 10 lakh, 1 crore, anything which comes in contact melts. That is why once it is out of control, everything will melt. That's why. Time 3 minutes.